Hey everybody, here's this week's tutorial where we're going to go over looping, screen coordinates, and randomness. So the important place to start here is with screen coordinates. This is really essential that you fully understand this. So let me start with something we're familiar with. I'm going to have my game functions actor create or spawn a red actor 100 pixels to the right of the game functions actor relative to actor. This is how we've been working. So if I put game functions here and preview, game function spawns the red actor 100 pixels to its right. Similarly, I could go into game functions and say spawn the blue actor 100 pixels to the left relative to the game functions actor. And there's our game functions. It spawns a red to its right, it spawns a blue to its left. But if we change these spawns relative to scene, now they no longer depend on where game functions is. So for instance, if I spawn the red actor at position 100 pixels to the right, 0 pixels above relative to scene, let's take a look at what happens. It's here. Because the origin, the 0, 0 point of the scene, is here in the lower left-hand corner of the screen. This is 0x, 0y. Relative to the actor, the game functions actor 0, 0 is at its center. So if I want something to appear in the left-hand corner of the screen, regardless of where my game functions is, I just position it at 0, 0 relative to scene, and you'll see the red actor will appear exactly in the corner. If I want it a little bit further to the right, I can say 100 pixels to the right of the left-hand corner of the screen. And there it is. If I want it a little bit above, I can say 100 pixels to the right of and 100 pixels above the 0, 0 point. This is I've achieved this by changing this to relative to scene. And this is independent of where my game functions is now. If game functions is over here, red appears in the same place, 100 pixels to the right and 100 pixels above the 0, 0 origin point. Even if game functions is not visible, red still appears in the same place. This is absolute positioning. And just memorize it. It's going to be different in each piece of software you use. The origin, the 0, 0 point in GameSalad is the lower left-hand corner of the screen. That is absolutely something you absolutely need to know. So that raises the question of what are the other corners of the screen? How do I find these other points? And this is a really challenging concept for certain students. So be sure that you spend enough time on this that you absolutely get it. If 0, 0 is the lower left-hand corner of the screen, then let's say the upper right-hand corner of the screen is going to be some positive value for x, some positive value for y. And this depends on the platform. The iPad screen is larger than the iPhone screen. The Kindle screen is larger than the iPhone screen, but smaller than the iPad screen. A MacBook screen is larger than all of them. So the pixel address, if you will, of the upper right-hand corner of the screen is going to vary from platform to platform, which is why, instead of worrying about what the specific number is, we let GameSalad tell us what that location is, because it's already stored in an attribute. So if I want to place something in the upper right-hand corner of the screen, I can spawn it. Let's spawn the green actor at the game display size width for its x coordinate and the game display size height as its y coordinate. And now green will appear in the upper right hand corner of the screen. to place something into the lower right-hand corner of the screen, that's going to be an X corresponding to the width of the screen, but a Y of 0. No height. We're still at the bottom of the screen. So let's go back in here again and put the blue actor at the position X game display size width, Y of 0. We preview it, and now blue appears in the lower right-hand corner of the screen. And this value is going to change depending on what our platform is. Maybe it's 640 pixels, maybe it's 1024 pixels. We don't know, and we don't need to know, because game functions knows and stores it in this attribute. So what I need you to do at this point is pause the tutorial and create a game where game functions places actors in all four corners of the screen so that you're confident with what settings are required. And remember, all of these have to be relative to scene, not relative to actor, so that if we move game functions, it doesn't change what happens on the screen at all. Okay, if you've come back from that exercise and you're confident about where the corners of the screen are, what the X and Y coordinates of the corners of the screen are, let's look at how to place something, for instance, exactly in the center. Game functions can spawn another actor. And where is the center of the screen? Well, we don't know numerically how wide it is or how tall it is, so we can't put in a number here for the center. And even if we did, and then we changed platforms, that number would be wrong. We can just say we're going to put it at half the width and half the height of the screen. So we can say game display size width divided by, and that's the forward slash, is division, divided by 2. So we're going to put it at half the width on the x-axis, and we're going to put it at game display size height divided by 2, half the height on the y-axis. And we're going to spawn, let's spawn another red. So this red is going to appear in the center. Except it doesn't. Why not? Here's the thing. Relative to actor. I made that error. I don't want it relative to actor. I want it relative to scene. So it's absolute positioning, and now there it is, boom, right in the center. Now why are these small in the corner and this one's big? Because 3/4 of this is off the screen. We're only seeing 1/4 of it because its center is at the edge of the screen. So now let's look at looping. And looping is a very, very powerful behavior because it allows us to do things multiple times in a controlled way. So if I wanted to create a red actor on the screen, and just so you know, I've added a couple of features. My red actor now has gravity, and there's a floor that it can collide with and bounce off of. It also bounces off other instances of itself. If I want to create multiple red actors, I can go into game functions and spawn a red actor. And let's put it at the center of the screen. So relative to the scene, I'm going to put it at game display size width divided by 2 and game display size height divided by 2. And if you're not clear on why this will put the actor at the center of the scene, you should go back, stop now, go back and review, because this is a really essential concept. So this is going to create one red actor at the center of the scene. And let's say I want to create 4 red actors all at the center of the scene. And because they have the collide behavior, they're going to bounce off of each other and separate as soon as they're created. And then they all fall and bounce. And there's our 4 red actors. But, and I just noticed that my floor needs to not be movable. But this is going to get cumbersome if we want to make, say, 50 red actors. I don't want to have to keep copying and pasting my spawn actor. What I'm going to do instead is put my spawn actor inside of a loop. Now, if I want to spawn 50 of them, I can just run this loop 50 times. For this, I'm going to need to create a new game level attribute. And I could create it as an attribute of the game functions actor, but for reasons we'll see later, I want to create it as a game level attribute. It's going to be an integer because I'm always dealing with a whole number of red actors. I'm never going to have 4.5 red actors. So I'm going to create an integer attribute, and oh, I already have it. It's called red count. There it is. So I can say, while all these conditions are valid, while the red count is, let's say we want to make 30. While the red count is less than 30, keep doing this loop. So every time a red actor is created, we need to change this attribute of red count by incrementing it so that it creates the first red actor and red count becomes 1. It does this comparison. Is red count less than 30? Yes. Make another one. Now red count becomes 2. Is red count less than 30? Yes. Make another one. All the way through 29. But then when red count becomes 30, this condition is no longer valid. The attribute game.redCount is 30. Is 30 less than 30? No. The loop will stop. So this simple structure here is going to create 30 reds all in the center of the screen. And if I want 100 reds, I just change this value to 100. And now this loop will run 100 times to create 100 red actors. All in the center of the screen. And as we looked at briefly in class, this max loops per frame determines how quickly this loop is going to run. A frame is, just like in video, when the screen redraws. So right now we're saying make me 100, but only let this loop run once each time the screen redraws. If I say 100, it'll draw all 100 of these red actors within one screen refresh, so much more quickly. And there they kind of all explode onto the screen at the same time. So we can do even more since we have this loop structure and this red count attribute. Let's go back to a more modest number like 10. Let's say we want those 10 actors spread out across the screen. Instead of putting them all at the center, I can put them at a location that's based on how many red actors are already there. So I can say game red count, and then let's say I want them spaced 40 pixels apart. I can say game red count times, that's the asterisk is multiplication, times 40, which means when the red count is 0, which it is at the beginning, the first red actor will appear at the left edge of the screen. The next red actor, when game red count is 1, will be 1 times 40, or 40 pixels from the left edge of the screen. The second, or actually the third, but when the red count is equal to 2, it'll be 40 times 2, which is 80. So the third red actor will appear 80 pixels from the left edge of the screen until all 10 have been drawn, like so. Also, since I've made this red count a game level attribute, I can have it affect other things. For instance, I could have it affect the height of each red actor. So I could add a change attribute inside the red actor that changes the attribute red size height to red size height plus red count. So each one of the actors is going to be a little taller than the last. Its own height plus whatever the current count is. And let's make the count a little bit higher. Let's make 20 of these so we can see the effect. Each one's a little bit taller. If I want to exaggerate this effect, I can say inside my red actor, set your height to your current height plus the red count times 2, and that's going to add twice the red actor count to the current height of each actor, and you can see each bar is getting visibly taller. Similarly, we could change another attribute. Let's say red's redness, and we'll change it to the red count divided by 20. So our actors are going to get brighter as they go across the screen, from dark to bright. So you can see, using loops in combination with attributes is very powerful. And loops can be inside of timers. So for instance, if I wanted to create 20 red actors every few seconds, I could just take this whole structure and put it inside a timer. But it's not going to work the first time. And see if you can figure out why before I show you. Say every 3 seconds, I'm going to create 20 new red actors, each one of which is positioned 40 pixels to the right of the last, each one of which is 5% brighter, and each one of which is taller than the previous, based on twice the current red count. And I'm doing this every 3 seconds. So I get my first batch after 3 seconds, and then I should get my second batch 3 seconds later, but I don't. Why is that? Pause the tutorial, see if you can figure that out, because it's an interesting detail that will become important in your work. Ooh, look, that's a strange one. All right, here's the solution. My timer counts 3 seconds and then does this loop. It does it until the red count exceeds, is equal to or greater than 20, and then it stops. And then 3 seconds later, it does it again. But what's the red count? The red count is already 20, so this condition is never met. If I want it to repeat every 3 seconds, I need to reset the red count back down to 0. So my timer would also have a change attribute in it. Change attribute red count to 0. So now red count goes up to 20, and then 3 seconds later red count is reset and I get 20 new ones, and then 20 new ones, and then 20 new ones. The flaw with this, of course, is I'm no longer keeping track of how many I actually have, because my red count is being reset every single time. And a simple solution to this would be to create yet another attribute that we'll call total red count. To total red count plus 1. And so every time a red actor is created, red count is incremented and total red count is incremented. But every 3 seconds, only this first attribute we created is going to be reset. And we can, to clarify things, we can rename that first. We can call it temp red count for temporary red count. there's temporary red count, which is going to reset each time we get 20 new objects, and the total red count, which is going to not reset. And just to see that that's working in game functions, we can put a display text. And this also is another place where we can use positioning relative to scene. I'm going to display my total red count in the lower left hand corner of the screen, which I'm going to do not relative to the position of game functions, but absolutely relative to the scene. So I'll put it 20 pixels from the left edge and 50 pixels above the bottom. And now there's 20 reds on the screen. Now there's 40, 60, etc. Finally, let's look at randomness and then combine the randomness and loop concepts into one. I'm going to take the same scene we've been working with, but I'm going to turn off our current timer and loop combination. And I'll turn off the display of text. And instead, I'm going to use a standard timer that creates a new red actor every half second. And I'm going to have it be a scene-based absolute position. But what I'm going to do that's different is I'm going to position it at the top of the screen, game, display size, height, but at a random location on the screen. And I do that by accessing this function menu. There's lots of functions here. We'll talk about a few of them. Right now we're just going to talk about random. This is going to, every time this timer comes around and every time the spawn actor behavior happens, pick a random number for the X coordinate of our newly spawned red actor. And we know that 0 is the left edge of the screen, and here we can really put in any value we want. If we want it spread across the entire screen, we'd use game display size width. So every time this actor is spawned, it will appear somewhere between the left and right edges of the screen at a randomly chosen location. Let's take a look at that, and let's see if it works. Yes. So each time it's created at a randomly chosen location between the left and right edges of the screen. Let's take away the red's accelerate behavior and randomly position these all over the screen. So rather than having them appear at the top, I'm going to have them appear at a random position somewhere between the bottom and the top of the screen. Now, my red actors will appear at a random X and random Y. And if they appear too close to each other, their collide behavior will come into effect and they'll bounce off of each other. But since they have no gravity, no acceleration, they just slide a little bit and then they stop. So random can be applied in lots of different ways. So for instance, we could also have each of our red actors have a random color. I'm going to use change attribute, and I'm going to change their redness to a random value. Now here things get a little tricky, because what's the range of redness? It's from 0 to 1. But if I try to do random 0 to 1, that's only two values. It's either a 0 or a 1, because random generates integers. So really what I want to do here is decide how many gradations between black and bright red do I want. Let's say I want 100 gradations between black and bright red. I take that and divide it by 100. And this is, again, very simple math. My desired output range is between 0, black, and 1, bright red. I want 100 shades between 0 and 1, so I generate a random number between 0 and 100 and divide it by 100. So if the random gives me a value of 50, 50 divided by 100 is 0.5. If random gives me a value of 100, 100 divided by 100 is 1. If random churns out a 0, 0 divided by 100 is 0. So whatever value the random gives me, I divide it by 100 to reduce that range down to a floating point range between 0 and 1. So now every red actor is going to come onto screen with a different brightness. So let's combine this with a loop. I go into game functions, and instead of using the timer, I'm going to use the loop. And spawn a red actor for as many times as the conditions of the loop are valid. So now I need my red count attribute again. My temp red count. I increase the temp red count by 1 every time a red actor is created, and my loop condition is when the temp red count is less than however many I want on the screen, let's say 50. And if I allow all 50 to be created in one frame, then I get 50 red squares at random locations and random brightnesses. As a final point, one of the things that we looked at in class was how we can add random ranges together in order to get different distributions. We talked about how when you roll dice, if you roll a single die, there's an equal chance of getting 1, 2, 3, 4, 5, or 6. But if you roll 2 dice, there's only one way to get a number 2, which is snake eyes. There's also only one way to get 12, 2 sixes. But there's multiple ways to get other numbers. So it's more likely, it's more probable that we'll get numbers towards the center of the range. So if I want a random but curved distribution, I can, instead of going, for instance, random 0 to game display size width, I could say random 0 to game display size width divided by 2 plus random 0 to game display size width divided by 2. My total range is the same from 0 to the display size width, but because I'm adding 2 randoms together, I'm center weighting the distribution. I'll do the same thing with the height. Random 0 to game display size height divided by 2 plus random 0 to game display size height divided by 2. And now we'll see that I get more blocks near the center than I do at the edges. And the more randoms I add together, the more extreme my center weighting is going to be. So let's shrink down our red a bit. And do it with 3 randoms added together. So I'll take the width of the screen divided by 3. And add it to yet another random 0 to game display size width divided by 3. So now this is the equivalent of rolling 3 dice. So it's going to be strongly center weighted. And I'll do the same thing here with height, divided by 3, divided by 3, and I'll add it to another random between 0 and game display size height divided by 3. So now I should get a strongly center-weighted distribution of reds with very few close to the edges. And if I increase the number, let's put 100 on the screen, I'll see that same distribution. Lots of reds near the middle, fewer near the edges. Take it up to 200, and still the distribution is clear. It's a strongly center-weighted distribution because I'm taking random choices and adding them together. Just like rolling multiple dice, the extreme values will become rare. So please go through this material carefully. I know it's a step up in complexity, but this is the direction we're headed in, and I wanted to do it in GameSalad rather than starting on this material in the next environment because it's, I think, a bit easier to grasp in GameSalad. But we're quickly running up close to the limits of GameSalad. There are things that GameSalad can't do that other multimedia environments do very easily. For instance, loops within loops. That is not something that we can do in GameSalad. It is something we can do very easily in pretty much any other environment. So please go through this carefully. Email me if you have any questions, and I look forward to seeing you in the next class.